Let's start with section 15.3, conservative vectors, fields, and independence. So for the first question, they ask you consider the following vector fields, fxy, which is mi and nj. So here's our vector x squared I plus yj. Show that f is conservative. So here's our vector. I write down in the component form. And if we need to check its conservative m sub y, if we find the derivative with respect to the y, here's m and here's n. For the y is going to be 0 and n sub x also is going to be 0, so it's conservative. Now the next step, verify if we have r1 with respect to the t equal t squared j ti plus t squared j and t between 0 and 1. So let's find, here's our r vector, which is going to be t and t squared and t between 0 and 1. And r prime is going to be, this is r1 prime, okay? So it's going to be, the derivative for t is going to be 1, the derivative of t squared is going to be 2t. So f with respect to the t, this one is x and this one is y. So we're gonna plug in here, and instead of the x is going to be t, so it's going to be t squared, and t squared here, plugging in the y, so it's going to be t squared. Now the integral f dot product with dr is going to be from 0 to 1, and here's the f, and here's the r prime with dt. So now it's going to be the integral. Let's do the dot product. Is going to be t squared times 1 is going to be t squared plus t squared times 2t is going to be 2t cubed. dt, find the integral. So it's going to be t cubed over 3, 2t to the power 4 over 4 from 0 to 1. And then plug in 1, so it's going to be 1/3 plus 1 over 2 minus 0. Multiply this one by 2, and multiply this one by 2, multiply this one by 3, multiply by 3. So the result is going to be 5/6. So the first one, this one, the result here is 0, and here is going to be 5/6. 5/6. I'm not going to do the second one when R2 to theta. You're going to do exactly the same steps, and from 0 to y. They ask you to find, you're going to get here exactly the same result. You're going to get 5/6. So you have to check that. I'm going to leave it for you. So let's go to the example 2. Example 2, they just ask you to find if it's conservative or no. So let's check number 2. So here's number 2. Here's our after the xy, 36x squared y squared, and 24x cubed y to the j. So I'm going to write down our vector in the component form. M sub y, here is m and here is n. Find the derivative with respect to the y. That means everything here is a constant. So it's going to be 2 times 36, which is 72x squared y. And n sub x is going to be also the same thing, 3 times 24, 72 x squared y. M sub y equal n sub x, that means it's conservative. So we're just going to choose this one. That's it for number 2. For number 3, you're going to get exactly the same thing. So you need to check if it's conservative or no. I'm just going to give you a hint. The derivative of d of dx ln to the u equal 1 over u du over dx. You're going to use this formula. So check that. You have to find m sub y and n sub x. But for this one, we have x, y, z. So you have to check. We're going to use the same rule with example 4. So for example 4, when you have x, y, z, x, y, z, if you have two coordinates, you're going to use m sub y and n sub x to check if it's conservative or no. But if you have x, y, z, you have to check m sub y. That means this is m, this is n, and here's p. So you have to check m sub y equal n sub x, and you have to check m sub z equal to p sub x, and you have to check n sub z equal p sub y. You have to check these three conditions to prove that this field is conservative. So the first thing, for example 4, I write down our f with in component 4, then m sub y equal n sub z, the first condition. So let's check. If we did this one with respect to the y, that's mean it's going to be cosine yz times the derivative of inside with respect to the y is going to be 1, so it's going to be z. So the z is going to be outside. The derivative for this one with respect to the x, for n with respect to the x is 1, so it's going to be cosine yz. So the first condition is satisfied. Now you just have to check the second condition and the third one. Check if these are equal, m sub z equal p sub x, and n sub z equal p sub y. That means f is going to be conservative. So I'm going to leave that also for you to check the second condition and the third one. For number 5, let's work on number 5. So here is our f, which is ye to the xy, xe to the xyj, and here is c1 and c2. So let's check here. I'm going to write down f in component 4, ye to the xy and xe to the xy, and r1 to the t equal t. And what I did here with the second part, I distribute. So here, t, and I distribute the negative sign, so it's going to be negative t plus 5. That's what I got here, negative t plus 5. And t between 0 and 5. So now f prime, this is x, and here's y. I'm going to plug in x and y here to get f with respect to the t. So it's going to be negative t plus 5 for the y, e for the x is going to be t, and for the y is going to be negative t plus 5. And here for the x is going to be t, e for the x also is going to be t, and for the y is going to be negative t plus 5. The derivative of r1 with respect to the t is going to be 1 and negative 1. So now the integral f with dot product with dr is going to be, here is the function f times dr, which is 1 negative 1 dt. So be careful here because you have two parts with the f. What I did here, I distribute. Check this part. When you distribute this part, is going to be negative t squared plus 5t. And we're going to distribute e to the negative t squared plus 5t here. So it's going to be negative t e to the negative t squared plus 5t plus 5e to the negative t squared plus 5t. So what I did here on this step, and here is the second part exactly the same. Now we're going to do the dot product. So it's going to be this part times 1. It's going to be the same thing, plus this part times negative 1. So it's going to be minus te to the negative t squared plus 5t. Next step, this one exactly the same thing here. So we're going to combine these together. So it's going to be negative 2te to negative t squared plus 5t. And here's 5. 5e to the negative t squared plus 5t. Next step, I'm going to factor out e to the negative t squared plus 5t. So the left is going to be 5 minus 2t. So in this case, you're going to let everything here is u. So let u equal negative t squared plus 5t. That means du is going to be equal negative 2t plus 5, which is exactly the same thing here. dt. That's why you're going to plug in everything here. This is u and this is du. So the integral is going to be just e to the u, which is negative t squared plus 5t from 0 to 5. Plug in the 5. It's going to be 5 squared, negative 5 squared plus 5 times 5, which is the whole thing here is 0, minus e to the 0. So it's going to be 1 minus 1, which is equal 0. That's mean for the first part here is going to be just 0. We got it right. Let's check B. For B, here's our function f to the xy, ye to the xy, and xe to the xy. So first of all, we're going to check if it's a closed path. So the first step we're going to do is to check is conservative or no. So this is m, and here is n. We're going to find m sub y. Be careful. I'm going to use the chain rule. So the first function times the derivative for the second one, which is e to the xy times the derivative of the exponents, which is x with respect to the y, and plus the second one, which is e to the x, y times the derivative for the first one with respect to the y is going to be 1. Now it's going to be xy, e to the xy plus e to the xy. Now n with respect to the x, so it's going to be the first one times the derivative for the second one. It's going to be e to the xy times the derivative of the exponent is going to be y, plus the second one times the derivative of the first one with respect to the x is going to be 1. So it's going to be xy e to the xy plus e to the xy. So it's conservative. That means f is independent on path. So we don't have to do exactly the same steps. So the integral of cf times dr is going to be exactly the same thing, which is equal to 0. So this one also equals 0. That's it for example 5. So you're going to do exactly the same thing for example 6, because you're going to get exactly the same numbers. There's no change in it. That's why I didn't solve it. Let's do number 7. So number 7, we're going to do exactly the same thing. We have R1 and we have R2. And here is our f to the xy. So for fxy, I'm going to write down in component form. R1 to the t equal t and 1 over t. And t between 1 and 3. R1 prime is going to be, find the derivative here is going to be 1. To find the derivative here is quotient, you have to use the quotient rule, which is going to be negative 1 over t squared. Now let's write down f with the t, with respect to the t. So t, here is x and here is y. So it's going to be 2x, that's mean 2t, and y squared 1 over t squared. And here's going to be 9t squared 1 over t. Now simplify this one. So here is our f. Because cancel this one with this one, cancel this one with this one. So it's going to be 2 over t, and here's going to be 9t. Now the integral with respect to the c, f times dr is going to be the integral. Here is the f, and here is dot product with dr dt. 2t times 1 is going to be 2 over t. 9t times negative 1 over t squared is going to be negative 9 over t dt. And we have exactly the same denominator here. So we're going to combine these together to negative 7 over t dt. Negative 7 is a constant. So the integral from 1 to 3, 1 over t dt, the integral of, which is going to be negative 7 ln to the t. And then this is from 1 to 3. And then it's going to be negative 7 ln to the t, ln to the 3 minus ln to the 1. Ln to the 1 equals 0. That means the result is going to be negative 7 ln to the 3. So the result for this one is going to be negative 7 len. Let's see, here's the functions. Len to the exterior value of 3. I think we have to write down like this, or just without write down like this. So for the second one, for B, we're going to do the same thing, but we have R2. So R2 is equal T plus 1 and negative 1/3 T minus 3. What I did here before I write it down, I'm going to distribute negative 1/3 here. So it's going to be negative 1/3 T plus 1. So here is the T. I have it here. And T between 0 and 2. So here is R squared prime to the T is going to be 1 and it's going to be negative 1/3. Our function F, just write it down again. So now I'm going to write down our function F with T. So I'm going to change. This one is X and this one is Y. So it's going to be 2X, which is T plus 1. And here is the Y squared. And here is 9. And here is X. And here is Y with X squared. So the integral is going to be from 0 to 2. And here is the F function times R prime dt. Multiply this one, because dot product with the first one is going to be the same. And multiply the second one times negative 1/3. So 9 with the 3 is going to be negative 3. And here is the left. I'm just going to write it down, dt. Now, next step, if you check, we have a common between these parentheses on both sides. So what I'm going to do, I'm going to factor it out. And the left here is going to be 2, one of these parentheses minus 3, and one of these parentheses, because it's squared here and here. What I'm going to do, write down these. Now distribute 2 and distribute negative 3. So here as we're going to get this one, combine the like terms, we get this part. Now next step, I'm going to distribute these two parentheses. So it's going to be negative 1/3 T squared plus T minus 1/3 T plus 1. Combine like terms. So we can combine like terms here. We're going to get, here is the next step. So after combining the like terms, we're going to get this one. Then we're going to distribute here by FOIL it here and this one also on 1. So we're going to get 11 over 9 T cubed plus 1/3 T squared minus 22 over 9 T squared minus 2 over 3T minus 11 over 3T minus 1. Now, next step, we're going to combine the like terms. We get this one. And now we just have to do the integral for each term by itself. So I kept 9 over 11 and T to the power 4 over 3, 19 over 9 T cubed over 3, 13 over 3 T squared over 2 minus T from 0 to 2. Plug in the 2, because when you plug in the 0, everything is going to be 0. That's why this 0. So now we're just going to simplify this one. It's going to be 44 over 9, 152 over 27, 26 over 3 minus 2. Multiply this one by 3 and this one by 3. We're going to get 132 over 27. Keep this one. Multiply this one by 9. So we're going to get 234 over 27. Multiply 2 by 27 over 27. So we're going to get 54 over 27. Combine everything is going to be negative 3 of 8 divided by 27. So that's the result for the second part, which is negative 308 divided by 27. That's it for number 7. So we got it right. That's it for section 15.3.